So hi everyone. So last class, that is on Tuesday, um, on 26th. So we have seen some of the basic concepts about our course. That is what is data mining, what are the real world applications of data mining. So I'm just going to give you a quick overview. Um, okay. So first, what is data mining? As we have discussed in the last class, that data mining is a process of discovering patterns in a large data set and involving various methods, that is machine learning methods at the intersection of various machine learning models, statistics, and database systems. So basically, the data mining is considered as an interdisciplinary subfield of computer science and statistics with an overall goal to extract meaningful information. That's what we need. So we discussed about the brief history about the data mining. It is before 1600. It was basically the empirical science. Then after 1600 up to 1950s, it was theoretical science. So all the theoretical component has been specified out. Then after that period up to 1990s, it was the computational theory or the computational science. Then, from starting with 1990 up until now, it's called data science. Okay, so um, then, as we all discussed, we have seen, not discussed, we have seen that data mining is mostly extracting meaningful or interesting patterns in the data from a large amount of data set. This is what the picture actually explains, and the brief um, labels or steps of data mining are mostly, there are a total 7 steps. So first step is here in this picture, they have been already specified 7 steps. So the data cleaning, then data integration, then data selection, then data transformation, then comes the data mining. And while data mining, you do the 6th step, that is pattern evaluation, then the knowledge representation or presentation. So see, every step has, again, it's not just pretty straightforward. There are various types of models, algorithms, methods available. So for each of the steps, someone has unmuted. So please mute yourself. Then this is a type of example of what data can be mined. That is the database. Here, if you have, as I have told you, if you have taken SQL or database system, you have seen the relational database system, and this is a type of data in which is organized in a typical relational database system. Likewise, we have data warehouse system or transactional database system. We will see some of the examples about them. That is data warehouse system and a transactional system. Then in this example, as you see, so let's say there is a store called All Electronics. You will also find this in the book as well. So if there is a store and which is a successful international company which is having different branches. So here there are the 4 branches here that you see around the world, and each branch has its own set of databases. And this is the basic steps overall overview of how the data is getting processed and meaningful patterns are getting evaluated or extracted. Then this is a picture. So this is the part where we should begin because all the other parts have been already covered in the last class. Mm, I just wanted to give you a recap. So we just see in one of the slide data, the mention of data warehouse. So this is a typical data warehouse system. If you see in the picture, you can enlarge yourself in your slide as well. Okay, this is a data structure or data. It is also called data cube, multi-dimensional data cube, or a data warehouse system. Okay, and here data warehouse, what does it mean actually? It usually modeled by multidimensional data structure, which is called a data cube, and in which each dimension, so if you see, it has multiple dimensions in it in each of the data warehouse system. So every dimension can correspond to an attribute or set of attributes in a schema. So if you see the first picture here, let's take the example of the last slide, the all electronic store. So the data cube, for the summarized sales data of all electronics, that is specified in this figure A. So this data cube has actually three dimensions that you see. So one for the city value. Okay. Yeah, one for the city value, that is the Chicago, New York, Toronto, and Vancouver. Then the time, quarter with quarter values such as various quarters of the time, quarter 1, quarter 2, quarter 3, quarter 4, and then items that those are mentioned here in the bottom part of this data cube. So the aggregate value stored in each cell of the cube is the cell's amount in thousands. Okay, let's say 605,000, 825,000, 395,000. Likewise. So for example, if we say the total sales for the quarter 1, that is Q1, for the items related to the security system in Vancouver, okay, so we can say that for Vancouver, this is the part which will point to, and this is, you can say that that for the quarter 1, the items related to security system Vancouver, it's actually 400 and the unit is in thousand, so it is 400,000, and this is the cell where it is stored. This is a basic specialization where the data is stored in a data cube structure or a data warehousing system or a data warehousing structure. Then there are other two structures as well if you see in figure B. So here, for instance, we can either drill down, apply the drill down method or the roll up method. So in the drill down method on the sales data, we are summarizing the data by quarter to see the data summarized by a month basis. Okay, time in month basis. It was in quarter, it is in month basis. And similarly, we can, if we can roll up, there is a roll up method, the data is summarized by the country name basis. Okay, so these are the basically this is it's I mean you are not going to see a particular application, just have to understand what is a data warehousing system mainly. Okay, then comes your transactional data. Like the data warehousing data, you have transactional data. So here what happens, it is always stored in this way. So each record in the transactional database, for a certain transaction, so here if you see transaction ID and the list of items, we are going to see particular application of this type of transactional data mostly. So there are different transaction IDs, T100, T200. So like this, it will go on. Then for each transaction, we have set of item IDs. So here, this is how actually the transactional data is being stored. Then comes what kinds of patterns can be mined. So there are different functionalities in data mining, and which is directly related to the meaningful patterns to be extracted from the data. And these are various concepts. We are going to see them in a proper way, in an elaborative way later in all other chapters. So let's just see a brief overview about all of them. Data, first you see characterization. So data characterization is a summarization of general characteristics, or you can say features of a type of data. Okay, and then discrimination, it is a, you can say it is a comparison of healthy comparison of general features of various data objects. Okay, so you can have the data can be divided into multiple classes. So when you make a comparison in between the features of different data objects, that goes in your data discrimination. So what are the different ways of visualizing the characterization and discrimination? That is using pie charts, bar charts, histograms. There are various ways of visualizing the data. Then comes mining frequent patterns, associations, and correlation. So what is this? A frequent item set typically refers to a set of items which will often appear together in a transactional data set. So if you uh, I hope during this COVID time you must have used the Instacart application, which gives you the online shopping platform for your day-to-day grocery items that you need. Okay, so while purchasing that, if you are buying, let's say milk, okay, in the same page you can get the recommendation of eggs or butter, correct? So how are you getting that recommendation? That is something, some programs or coding has been implemented, or some techniques have been implemented, so that when you are buying a particular item, it is giving you the certain types of recommendations based on current um, um, buying history or purchase history. So there are different types of models and techniques again, understanding this association, frequent patterns. So there are other concepts. We will look into that. Then comes classification, regression, clustering analysis, and outlier analysis. Let's see them in next slide. So before that, first we will see what is association analysis, just to understand this concept. Mostly, what is this? I gave you one example of that purchase history of Instacart. So here, if you see, uh, here we have the same all electronic store, and in the all electronic store, we are keeping track of certain information of items which are frequently purchased together in a same transaction. So each type, here you can create rules based on the items frequently purchased together. Those are called rules. Again, there are different forms of determining the association rules from the transactional data. So let's see one example here. Here you see this is the statement. Okay, buys X computer, tends to buys X software. So this is an association rule, and these are support and confidence. These are the two measures based on which you determine which is a strong association rule. So what does it mean actually? So here X is a variable representing representing a customer. Okay, and here the confidence is called as, also can be called as certainty. So here 50% of confidence, it's mean that if a customer buys a computer, then there is a 50% chance that he or she will buy the software as well. That is the meaning of confidence. But there is a formula to determine that. We will see that in another one chapter. So there is a support of 1% means what? Support equal to 1%. It means that 1% of all the transactions under analysis, so that the computer and software are purchased together. So these are two metrics which will determine what are the frequent sets or frequent item sets which are supposed to be generated or generated together. Basically, in this case, the frequent items which are to be purchased together. Uh, then if we drop the single predicate, that is the X, then the association rules becomes like this. So here 1% tends to support and confidence tends to 50%. Like that, there is one example here if you see in the bottom. So let's say the association rule is in this format, and support is 2% and confidence is 60%. What does it mean? It's basically the similar one, but we have two conditions rather than one. So what does it mean? The rule indicates that here the support 2% means, so 2%, that is The customers which are under the study for this association rule, those are in the range, age range in between 20 to 29. Those are 20 to 29 years old with an income of $40,000 up to starting with 40K to 49K. They have purchased a laptop or a computer. Okay. And then there is a 60% probability that a customer within the age range of 20 to 29 and the income group of 40K to 49K will likely purchase a laptop. This is the purchase product laptop. This is what it means, correct? So like this, you can add multiple conditions. Rather than two, you can also have three, and the support and confidence will determine their frequent item set generation. Then comes classification, another part of your frequent the kinds of patterns which can be mined. So that this is another one basis or criteria. Classification and regression. So here, if you see in this picture, these are three different ways of showing the classification model. Classification means classifying different types of data sets. It's simple. So classification is the process of finding a model which will describe and distinguish the different types of data or different types of concepts. The model are derived will be based on the analysis of set of data. So here, when we do a certain type of data analysis, we can divide the data set into two different sections, that is training data and testing data. Okay, let me mention it here. So two different sections in which we can divide our data set. What does it mean? See, we are not going into the implementation part, just for your understanding I'm saying. So if you have a data set of this size, so it will divide it into, let's say, 50%. Okay, 50%, 50%. 50% goes to train and 50%, rest 50% will go to test section. So first you will apply a certain model. Using the model, let's say you want to learn something from your data, meaningful pattern. So first you need to train the data using that model, and whatever output you get, again using that, you apply that output from the training part to the test part to see whether you are getting any accurate result. So these are different ways of data partitioning as well, and it is also helpful in the classification process. So once you do the classification, the model will be used to predict the class level of objects for which the class level are unknown. Something unknown, you basically learn the knowledge after doing the classification.
Oh,
Now,
sorry. Is this class in person?
sorry, say
Oh,
again.
this for data structures.
Data structure means you are saying asking about a specific image here or picture here.
Oh no, like the classroom for data structures, since it was a hybrid course.
Data structures.
Oh, data mining, sorry. Data mining was hybrid.
Data mining, yeah, it's hybrid. Why?
Oh,
What
what
happened?
classroom?
Yeah,
Oh, I walked into the wrong classroom for data mining.
this is the data mining class.
No, no, no. I mean, is it in a classroom?
We are here in the classroom. Thursday it's online.
Oh, okay. Sorry, I read it wrong then.
Yeah,
Apologies.
it's hybrid. So Tuesdays are on ground, Thursdays are online. Okay.
Okay.
Okay. Yeah.
Okay.
Mm-hmm.
Sorry.
Yeah, that's fine. So now, so these are the three different types of representation of a classification model. Either you can use just if then if then. Okay, like let's say if you have taken a programming class, you must have seen branching or if else rules. So like this is an if then rule. Then you can represent it using a decision tree or a neural network. This is a most complex one. Let's not go into that. So if you see this decision rule, so there are there are different types of rules or statements available. So somebody's age. So using the criteria youth, you determine the income. So if the income is high, then it belongs to class A. If the information is income is low, then it belongs to class B. So and then age, if it's a middle aged or senior, then it belongs to class C. So this is how a particular set of association rules can be classified, and we can have meaningful information from that. So now what are the applications for it? So different types of typical applications. So you must have, I'll give you a simple example. So you have email, right? Let's say you have Gmail. So particular Gmail, there are different sections. Either you get some emails in the primary section, you may get some emails as a spam section. So how do they actually classify the emails as per importance? If they are important and from the legitimate source, then it goes to primary, or else it goes to the spam. So there is a filtering options being enabled in Gmail, and in that way it classifies all the emails which are important and which are not important. Likewise, it can be applied in credit card fraud detection, in marketing, or classifying different types of diseases. Okay, so these are some of the applications in which we can apply the classification rules. Then the next one is cluster analysis. So in the slide 9, where you have what kind of patterns can be mined, if you remember, we have different criterias and different structures, and we are just going through them. So the last one is cluster analysis. See, it looks simple, but again, cluster analysis are a bit more complicated. It's not pretty straightforward. So if you have the data set in this way, so let's say you have different types of fruits. You have 5 apples, 3 oranges, and some other type of fruits as well. And let's say actually when you want to train a machine, okay, to give you a result of whether that fruit is apple, orange, or something else, so the machine actually need to learn something, right? So there should be some criteria. So the apple color is red, orange color is a different color, or shapes are different also. So those things are needed to be fit to the machine so that it will be able to distinguish between different types of fruits. So the same type of method will be applied to cluster analysis. So here you are distinguishing three structures based on their characteristics, features, their behavior, their attributes, and everything. So sometimes there are different algorithms, and sometimes we may not also be able to get proper or effective clusters from our data. There are different cluster defining algorithms. We will see them in later on in other chapters. Uh, that is your cluster analysis. Next, if you are learning clusters, about clusters, doing the classification for defining clusters, then comes your outlier. So what is outlier? So if a data set may contain objects that do not comply with the general behavior or model of a data, then the data objects are outliers. Okay, uh, let's say you have different types of fruits. So let's say this is apple, this is orange, this is pineapple. Then you have another data. Suppose this is a cat, this is a dog. Okay, and then you have let's say a gallon of milk, or a packet of eggs, right? So I'll just change the signs. So on the basis of certain criteria, you will make form you will form cluster. Okay, so in this set, if something is totally different, let's say what I will consider, let's say human being. Okay, a human being, a different type of entity. So this human being will be a total outlier or external entity to this whole data set. Okay, so this becomes your outlier. So okay, so outlier analysis, how it is applied in what applications actually. So outlier analysis may be able to uncover fraudulent uses of credit cards while detecting purchases of a large amount of given account numbers in comparison to regular charges incurred by the same account. So you have multiple types of purchases in your account, but this outlier analysis maybe help you track down the fraudulent uses of the credit cards. Then, if you are learning the data, you want to mine the data or extract the data, then um, then what are the types of patterns that are interesting? Okay, so that is again important to you. So if you have a given data set and you are trying to mine or extract information from it, so while mining also, there may be, let's say from a given data set, you have 10 rules or 10 patterns. So out of 10, there may be 20% or 30% of rules which may not be important and which may not be helpful for using that data again in your further research, right? So in that case, the pattern's interestingness measure comes into picture, and the pattern interesting measure does have some methods available. Using those, you decide whether the patterns are interesting or not. Then these are some of the technologies which are associated with data mining. So if you see, we have, I already told you about statistics, we have machine learning, so database system, warehousing, visualization, so pattern recognition. These are some different areas and they are all interrelated together like this. So you need to have a little bit information about all the areas so that you will be able to do proper data mining on your data set. Then next, some of the important concepts to be covered. So in a machine learning is highly related to your data mining. Okay, so it's really important, and for data mining you need you need to learn different type of machine learning, and these are the four different types of machine learning. So supervised learning means it's a its different name can be classification. So the supervision in the learning comes from the labeled examples in a given data set. Okay, so let's say suppose you have a postal code recognition system. So a set of handwritten postal code images and the corresponding machine readable translations, which can be used as helpful data or training example. So they will be able to supervise the learning of the classification model. Okay, so unsupervised learning is a synonym or is similar to your clustering. So here the learning process is supervised since the input examples are not class level. Semi-supervised, I'll show you in the next slide what is it. Then comes the active learning. We will see more examples about those in other chapters. We are just going through the basic concepts actually, their definitions. Then your active learning is what? This is a different type of approach in which it lets the users play an active role in the learning process. So here, in this approach, you can ask a user to label an example, which may be a form of unlabeled examples by the learning program. And here the goal Our ambition is to optimize the model equality. Okay. And it can be acquired by the direct knowledge from the human users. Next, your semi-supervised learning. Here what you do, semi-supervised learning, machine learning technique, it uses both labeled and unlabeled examples when the learning, when we are learning a model. So in this approach, labeled examples are used to learn class models and unlabeled examples are used to refine boundaries between the classes. So if you see in this picture here, we have all these labels are being provided, what all these symbols mean actually. So if here it says if we don't consider the unlabeled example, okay, then the dashed line is the decision boundary which best partitions the positive sample from the negative sample. This is the decision boundary. But just in the alternative case, so if you are using unlabeled examples, then we can refine the decision boundary to this solid line. So here we can say that we can detect the two positive examples in the top right corner, which are again labeled, and they don't actually they are not actually similar to all these set of data, and this becomes the noise or the outliers which doesn't have any common characteristics or pattern that all these set of attributes have here. Then database systems and data warehouses. Here, the database system research actually focuses on creation, maintenance, and use of data bases for organizations and end users. We know we just got some idea about the data warehouse and information retrieval as well. Then different applications of data mining. So in web page analysis, various recommender system for recommendation. We saw that association rule, if you remember in the previous slide. Then recommender system is also similar to this basket data analysis and target marketing in the business or economical purpose. It's used. Then in the biological medical field, it's used in various data mining software engineering field and from major dedicated data mining systems tools. So here the most important, I mean, you may have heard about business intelligence. Okay, so this is an application. So business intelligence, it provides the historical, current, and predictive views of business operations. So one application can be that as well. Business intelligence is a major short application of that data mining. Then we can give, if you see the web page analysis, so the web search engine, if you know, so it will have a specialized computer server, which is mostly dedicated to searches of the information on the web. So there are various fields of data mining. So some of them are listed here. So for more details, please read the book and you will have more idea on it. So what are the different issues in data mining now? What are the problems or disadvantages? So some of the major issues are efficiency and scalability. So and it, if we have diversified data types, so if you have different types of data types, then handling for that complex set of data structure and then again mining them, it is handful. I mean, it's really difficult to keep track of that data and to manage it. So and again, the data mining does have various social impacts. There are privacy issues as well. Okay, these are the different issues of the data mining, and I have given you some of the references the brief history about the data mining society here. You can refer to all these references for knowledge, for your own knowledge. And these are some of the conferences and journal in data mining, some of the recent works. You can refer them and you can gain more knowledge and details about data mining. Some of the other slides also I have included important resources from CiteSeer and Google. So they belong to different types of fields here. For data mining, database systems, AI, statistics, visualization, there are different fields of data mining. And these are some of the most famous journals, and you can refer them. Okay, so this ends with our first introduction, that is chapter 1. What I'm going to do, I'm going to make the second one available, which I just want to get started with the second one here also. You can go to Blackboard and open the presentation, and yeah, here is the link, the learning objective I have posted, and the presentation link. The assignment is not available to you. I'll provide it when I'll assign it when we will complete this second chapter about data. Okay, just give me one moment. Data mining. I'm just going to stop sharing my screen for a while. Okay, there you go. The second chapter, it's about data. Hmm, okay. Okay, these are the major points that we will be covering in this chapter. Various types of data objects, attribute types, then basic statistical description, different descriptions about data, various visualizations, um, then data dissimilarity and similarity measures. Okay, so if we are learning about data sets, so there are various types of data sets actually. So first one, if you see, first type is record. So you may have if you remember the relational database I was explaining about. So that relational record is one type of record system or record data set. Then we have graph or network. So one of the graph network, it can be World Wide Web data, social, that is any social networking website data, ordered data, and spatial image and multimedia data. So if you see the record has a criteria of document data. So a document data actually looks like this. We will be using this type of example in this chapter for learning a specific concept. And here the document data looks like this, where you have 3 documents and each document has specific attributes in it. So document has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 attributes in it. And each document 1 has this attribute frequency as 3, coach frequency 0, play frequency 5. Then the transaction data, you have seen this in the previous chapter as well. So the transaction data actually looks in this way. You have 5 transactions here, and each transaction have this set of item sets. Then some important characteristics of structured data. So there are various research challenges in data analytics. Okay. So first, curse of dimensionality means what? So we have multidimensional data structures, right? So due to this dimensionality, complexity in dimensionality, we can do dimensionality reduction. Okay. So what is this dimensionality reduction actually is? When you have a proper data set and you are going to apply some sort of machine learning algorithm or model in it, you need to first change the uh, change visualizing the data. I mean, how do you want to I mean, how can I explain? How do you arrange your data in a certain way so that they will be in a particular range? I can give you one example. Let me write it here. So if we have, there is a data, okay? We have age data and salary data, okay? So there are age like 20, 21, like this we have up to 50. Then we have salary such as 50,000 suppose, like this up to let's say 90,000. Okay. So just see what is the range here. This is in 2 digits and this is a bigger range. So if you are going to apply a model in it, your model may not behave properly. So in that case, you need to standardize your data or normalize your data. That is your dimensionality reduction, so that they will be in a proper one format. So one format. So what does it mean? If you standardize or normalize the data, what happens? The data will be converted to a certain format and it should be within a range of 0 and 1. In the similar way, this also can be reduced and the values will correspond to and fall within a range of 0 and 1. See, if both of them are in 0 and 1 range, now they will be easy to handle. Hope you understood it, what I'm trying to say. Then comes your sparsity. So sparsity is the idea that if there is a value 0, which has to play a special role, and then something unusual has to happen at the value of 0 as well. And there may be discontinuity of your data in that case. Then comes resolution. So you may have certain patterns which are large in scale and some certain patterns which are smaller in scale. So in that case, that is a criteria you have to consider. Then next is your distribution. You have to also pay attention to the distribution of data. Next, data objects. So your data object actually is nothing but a data entity, and it represents an entity, and some of the examples are the cells database can be so here for the cells database, the objects can be the customer, store items and cells. Then in medical database, the objects can be patients and treatments. Likewise for university database. An attribute is a data field representing the characteristics or feature of a data object. So if you see this one here. Okay, so these columns are nothing but the attributes, and these three are data objects. Then some more about the attribute. So attribute can be called as dimensions, features, or variables, and these are the data field which directly represent the characteristics or feature of data object. There are various types of attributes actually: nominal, binary, numeric. And now numeric is again two types: interval and ratio scaled. So see, this type of attributes, the data, these are basically important, and you may get questions from it in the assignments. So let's see the nominal one. Here, the nominal attribute, these are nothing but the symbols or name of things. Okay, so the nominal here, each value represents some type of category, code, or state, and also the nominal attributes are referred to as categorical, and these value do not have any meaningful order. You don't have to obey any order. So hair color, marital status, these are the types of nominal attributes describing a person object. Okay, your hair color, marital status, occupation, ID number, chip codes, they don't have to obey a particular order. Anything, a noun type, name type, that comes under the nominal. Then comes your binary. So binary attributes are referred to as a Boolean. You know Boolean, right, in the form of zeros or ones. So Boolean if two states correspond to either true or false. So if you are you have given an example, okay, a smoker describing a patient object. So if you have a value of 1, a binary attribute value as 1, so it indicates that the patient smokes. 0 if the patient doesn't smoke. These are two values or formats of binary um, attribute. So you may have, this is a special case, you know, in binary. If a particular type of attribute, nominal attribute, it has two states. Here hair color, it has 1 2 3 4 5 6 7. Okay, 7 states. But let's say you can say marital status. Marital status can be multiple. What type of binary? Gender. Okay, gender, it can be male or female. Just generally I'm saying. Okay, so that is a special case where it can become a binary attribute. That's what I'm trying to explain you. Okay, so symmetric binary that I was just telling, both outcomes equally important. If in a binary type of data attribute type, you have a specific example as gender. So here, whatever the outcome may be, maybe the female or male, the both of them has equally importance. Nothing, no one of them is more, and no one, neither none other one is of less. They are equally important with each other. Then asymmetric binary means what? So here outcomes are not equally important. What does it mean? So let's say you have a medical test. Let's say HIV test. If you are getting a positive, that is 1, and you are getting a negative as 0. So what does it mean? Are they equal? Are they symmetric binary? No. Why? If you are getting a positive result as 1, then there you have to be more careful. You have to be under the medication. You have to follow the doctor's prescription, whatever he is saying, he or she is saying. If it's negative, you don't have to worry about anything. So these are two different types of binary. You have to remember what is symmetric binary, what is asymmetric binary. Symmetric binary means have equally importance. Both of the values 0 or 1, they have equally importance. If 0 and 1 doesn't have equally importance, then it's asymmetric binary. Then the next type is ordinal. So here ordinal, here there should be a proper order or ranking of magnitude. So let's say size, or let's say you have grades or army rankings. So you have grades, right? So like A, B, C, D. Then if there are different grades and there is a proper ordering, you have a range of points available for each grade, correct? So where you follow a specific order, that is your ordinal. Then comes your numeric attribute. The numeric attribute mostly specialized in the format of quantity. So it's quantitative. That is, it is a measurable quantity represented in integer or real values. It is assigned with some sort of quantity or numerical values. So there are two types: interval scaled attribute and ratio scaled attribute. So interval scaled attributes are measured on a scale of equal units. Okay, and the value of this type may have certain order. It can be positive or negative. So if you have and one thing, they are measured on a scale of equal sized unit. So if you have the values in a order, temperature in centigrade or Fahrenheit or calendar dates, so they are in a specific order. So considering, let's say, each day as an object, let's say we are taking an object as a day. So temperature of each day can help with determining the ranking of objects with respect to temperature. So if temperature is high, then that is a different day. If temperature is below zero, then that is a snow day or colder day. So likewise, you are distinguishing the days based on the interval scaled attribute values. So if temperature is in Celsius, Fahrenheit, which do not have a 0 point, okay, that is neither 0 degree centigrade or 0 degree Fahrenheit indicates no temperature. So mostly, if you have the best example is temperature, which have certain form of intervals in it, equal sized units, then that is considered as interval. Then ratio. So ratio scaled means it has the properties of an interval variable. And here, if we say, let's say the example is 0 0.0. So if a variable will have a value 0 0.0, then there is none of that variable. Okay. So it has an inherent 0 point. So interval doesn't have a true 0 point. We are not relying on the 0 point, doesn't have a meaning. But in the ratio, it does have a 0 point in it, and 0 point has a specific meaning. Um, So some of the examples are temperature in Kelvin, length, counts, monetary quantities, all those. So you have to keep in mind that interval doesn't have a 0 point and ratio does have an inherent meaningful 0 point. Okay. In the basis of that, you need to distinguish these two types of attributes. Then next is discrete attribute types: discrete attributes and continuous attribute. So discrete attributes has a finite or countably infinite set of values which may or may not be represented as integers. So you can take the example of zip codes, profession, or various types of documents. Okay, and in any type of attribute which can be represented with integer variables, that is your discrete. So if you remember the binary attribute in the last slide, binary attribute can have two forms of data, that is 0 and 1. So this is a special case of discrete attribute here. Then continuous. So if a attribute is not discrete, then we can consider it as continuous. And they are not restricted to defined separate values. Okay, but they can occupy any value within a continuous range. So between two continuous data values, there may be infinite number of other continuous values as well. And continuous attributes or continuous data are always essentially numeric. So any real numbers, So it may be as attribute value, it may be temperature, height, or weight. Discrete attribute cannot have any real type of number. And here it can be real values can be represented with finite number of digits. And it mostly correspond to the floating point number types, not integer types. So integer type correspond to discrete, floating point type correspond to the continuous attribute. Okay. So that was all about your data objects and attribute types of second chapter. In the next class, we will start with the basic statistical descriptions about the data. Okay. So that's all for now. So 1 moment.